Hi. So let's get into another somewhat difficult problem, number 18. This says evaluate the integral of y plus sine of x dx plus z squared plus cosine y dy plus x cubed dx, where c is the curve sine of t, cosine of t, sine of 2t from t equals 0 to 2 pi. Okay, so the hint is observe that c lies on the surface z equals 2xy. Now, how do we even know that that is a true fact? Well, this follows because you have this this equation, right? Like this, okay? So sine of t, cosine of t equals 1/2 sine 2t, right? You may also see it like this, where you put the 2 in the front. And so a way to remember that is that if you have a sine of 2t, you can just push the 2 out, and then when you do that, you also pick up a cosine. Okay, so if that's the case, right, then this r of t is equal to sine of t cosine of t, and then 2 sine of t cosine of t. Okay, and so where do they get that your curve lies on the surface z equals 2xy? Well, if this is x and this is y, this is z, then z equals 2xy. That's it. That's all it is. Pretty straightforward, and it's going to be very helpful. Okay, so let's get right into this calculation. Okay, so here we go. Here is the solution. So this, by the comment in previous videos, is going to equal f dr over curve C, and by Stokes Theorem, this is going to equal the double integral over surface S curl of f dot ds. Okay, so let us now compute the curl dot ds. So this is I, j, and k. Let me expand that a little. Here we go. Y plus sine of x, j del y, z squared plus cosine of y, and the last bit is going to be k del z x cubed. Okay, good. Dot ds. Great. So what is this going to equal? Well, the partial derivative of x cubed with respect to y, that's going to be 0. When I do it over here, I get a 2z. So I get a negative 2z. And if I just keep going, I get, let's see, negative 3x squared minus 0 and minus 1. Okay, dot ds. Okay, so it's okay for us to have a z still at this point because I still have the dot ds. So I'm still, I haven't introduced the RT thing yet. Okay, I like to introduce that when I switch $sign S to regular S. Okay, so let's go ahead and do that. Well, over here, let's do a little side calculation. What exactly is r of x? Well, r of x is well, let's think about it. Do I want to use sine and cosine? Not really, right? So I don't have x, y, and z, right? I don't have regular x's and y's in here. I have t's, and I guess you could say that if I have a t, then I have a u and a v, where u is a constant, say 1, which would be the radius, let's say, and then v would be t. But then I got to deal with sines and cosines, taking derivatives of that, and that does not sound fun at all. So what am I saying? I'm saying that I could compute, if I think of this as a function of t, I could compute derivatives with that. I don't want to do that. What I'm going to say instead is that r of x, y, okay, I've converted it now, r x, y, this is going to be x, y, and 2x, y. Okay, so that's nothing too complicated. It's what I said earlier, right? And now we're looking at the surface, okay? So I'm going to rewrite this as the double integral s, negative 2z minus 3x squared minus 1 dotted within ds, okay? So think of it on the surface, and I want to know what this in is. Okay, well, once I compute r of x, this is going to be 1, 0, 2, 2y. R of y is 0, 1, and 2 of x. And so r of x cross r of y, that is going to be negative 2y, negative 2x, and 1. Okay, so instead of in ds, you can also have rx, ry, dA. But the thing here now is we need to switch this z into 2xy, right? So 2xy, and so I'm going to convert that right now. This will be times 2xy. Okay, so let's clean this up. Okay, so this is going to equal the double integral over the surface S I apologize. Once we introduce this, this should have a d, and so that should have a d. So apologies for that. So we have that. So this will be negative 4xy and negative 3x squared minus 1 dotted with this right here, which I just found, so negative 2y minus 2x and 1 dA. Okay, so let's go ahead and clean things up, compute the dot product. This should give us 8xy squared plus 6x cubed minus 1 dA, and okay, so think back to the shape that we are working on. So you have sine, cosine, and sine of 2t. Right, so what exactly is it? Well, it is a circle, right? But not quite. Okay, so it is not quite a circle. It's like a circle working backward, right? So let's think about our usual circle, right? So our usual circle is going to have cosine t and sine t, and when t increases, right, the circle is going to trace in that direction. So as t increases, the horizontal component, the x component, is going to decrease because you're moving in this way. So x decreases and y increases. Okay? Now, if you simply swap sine and cosine, you're going to swap the order of the thing you trace, right? So what we have is sine and cosine, not cosine and sine. So, okay, so if t is equal to 0, then when t is equal to 0, sine is equal to 0. And this is the x component, so it's going to be here, it's going to be 0. And when cosine is equal to 0, that's going to give me 1. So I'm going to start up here because x is 0 and y is 1. Now, remember that when t increases, the cosine decreases, right? That's what I mean by x decreases. But this time cosine is in the y-coordinate, so it's going to go down, right? Because here cosine decreases, right? So here it's going to decrease, while the other one is going to increase. The net result is you're going to have this sort of thing, right? This is when you have sine of t, cosine of t, which is what we have up here. Okay, so why did I say all of this? Well, the point is that when we do Stokes theorem, when we use Stokes theorem, we normally assume a positive orientation, which means you're going counterclockwise. But in fact, we're going clockwise, right? Because r of t is equal to that, and t is increasing. So it's actually going clockwise. So what does that mean? Well, it means that we actually have to go back and we have to reintroduce negative signs, right? We have to introduce negative signs because at the very beginning, when I wrote FDR C, this C was not counterclockwise. It was not positively oriented. It was negatively oriented. So what we do is we're going to negate that so that our curve is going in the opposite direction. That's what the minus sign means. And then when you do that, you pick up a minus sign, right? It's no different than if you integrate, say, from 1 to 0, you negate 1 to 0 by flipping the order, which is what this minus sign means, but you also pick up a negative sign. So that's what we did. So basically, go back add a negative sign to every single step, and now you are correct, okay? So I didn't want to do it at the beginning because I didn't want to get hung up on some theoretical bit. Okay, so hopefully that makes sense why I introduced a negative sign. If not, start over from the beginning with that in mind, and it should make more sense. Okay, right. So anyway, so I am going to look at D, and D is the domain which underlies this circle thing. So keep in mind that the sine and cosine here, it's going to give me essentially a circle, right? But Z is going to depend on sine of 2t, so it's really gonna do something like curl up like this, right? I'm not saying I know exactly how it looks, okay? I'm not going to pretend for a moment that I know, but the point is, if you ignore Z, it crushes down, right? And it's going to look like a circle. And whenever we consider D, we always consider the shadow, where we crush the thing down. So effectively, we're dealing with a circle. Okay, so we're going to crush it down, and you just get this circle part right there. Okay, great. Now that we have that in mind, let's go ahead and use a change of coordinates to make this work. We're going to convert using sine and cosine. But at this point, we're going to use just ordinary sine and cosine, ordinary polar coordinates. Okay, so you're going to say, let x equal cosine r of cosine theta, and let y equal r of sine theta. Okay, and when you do that, once you do that, this is just an ordinary algebraic manipulation. You can do that. So you should get 8r cubed cosine theta sine squared theta plus 6 times r cubed cosine cubed theta minus 1, okay? And then r dr d theta, it's the usual trick. And remember, we're dealing with a circle once we've crushed the spring down. And so this is going to go from 0 to 1, right? R is going from 0 to 1, and then 0 to 2 pi. Okay, so after you've done some calculations, you should get 0 to 2 pi and 8 r to the 5th power, right? So when you integrate with respect to r, the 3rd power is going to become there's an r and an r cubed, so that's going to be 4th power, and then when you integrate that, you get a 5th power. So that's where you get the 5th power. So at the end of everything, you should get r to the 5th power cosine theta sine squared theta plus 6 r to the 5th power cosine cubed theta minus r squared over 2, 1 to 0, and again here, well, you're evaluating the whole thing from 1 to 0. Okay, and when you do that, the thing you get left over with is negative 1/5 0 to 2 pi, 8 cosine theta sine squared theta plus 6 cosine cubed theta plus 1/2 d theta, 0 to 2 pi. Okay, take a moment to look at that. And now look, this this part right here, right, that has a factor of cosine, and this has a factor of cosine. So what we're going to do is we're going to factor out the cosine. And so you should get cosine, right, sine squared, plus 6 times cosine squared, plus this part right here, right, that other integral. Okay, we're almost done. Now, this right here, this cosine squared, I don't like that, because what I want to do is I want to do a u substitution, where u is sine and du is cosine, right, with that. So what I'm going to do is I'm going to remember that sine squared plus cosine squared is equal to 1. And so I can rewrite this cosine squared as 1 minus sine squared theta, right? So this whole bit right there is going to go away, right? Because if I say let u equal sine theta, du equals cosine theta, well, now I've got a u and a 6, 1 minus u squared, right? And it's almost clear now, okay? Because u is equal to sine theta, so plug in 0 here, you get 0. Plug in 2 pi here, you get 0. So it's 0 to 0. So all of this goes away, and now we're left over with just this. And if you compute that, it's clearly just pi. And so the answer is pi. I'll see you in the next video.